Okay.
Yeah. Hello everyone, my name is Bin He, and this is my topic for the seminar, protecting privacy sensitive information for multimedia. Let's start.
Just go in the first position.
Here shows some picture of how users' privacy sensitive information exposed to the public. Look at this picture. People go everywhere and they geotag their picture. Others will know where they are. What exactly are they doing? And some personal information are included in it, maybe. And the second picture shows the geo-coordinator inside the iPhones, and they can tag your picture, video, as well as the time. And this is LBS. People use mobile devices and they expose their locations to the LBS provider, and the provider provides them services according to the locations they provide. This is a surveillance camera, and according to a survey in London, the average frequency for every citizen exposed to the surveillance camera is 300 times per day. And this is a picture of Optio Delft. If you take picture in front of this building, there are two possible ways for others to know it. The first, they know this building, they can recognize the background. The second method is that they can upload this image to on the internet, and they can compare it by using the Google image. Yeah. Let's talk about the methods. First is the geotag method. This is a method by setting the limitation. People who can see it, as you can see, you tagging, and you can point out, you prevent who to see it. And this method I think is not good, and I have two suggestions. The first drawback of this method is that you cannot list all the potential attackers, and the second is that your friend can see it. They can repost your image. In this way, other people can also know it. And this is cool. I think you can choose the accuracy of the location, like the country, region, city, block, house. Yeah, if you want to share your picture with your friends or relatives, you can choose the house or block. And if you want to share it with the strangers, you can give more bigger places, like the country, region, just the city. Here's the method for LBS. There are three methods. One is anonymity, one is obfuscation, and the other is policies. Here's the classification of the LBS. There are 7 categories, including the navigation, information, tracking, emergency, advertising, billing, social networking. Yeah, this is a method, anonymity. This is a key anonymity. From the first algorithm, we know that a user, let's call it UA, UA receive location information from other K-1 users and calculate the central and send it to the provider. The provider provides services according to the central. This is not safe. Why? Because the user UA can know the exact location of all other K-1 users. So we improve this by adding the Gaussian noise as a second algorithm shown here. In this way, the user UA cannot know the exact location of other K-1 users. And the central is the same, because the mean of the Gaussian noise is 0, so it's the same. But there is one drawback for this. For example, if a user exposes his location dynamically while he stays in one place, it will expose his real location, and the user UA will know it. We don't know whether UA is a trusted or untrusted user, right? And let's come to the third method with public keys anonymity. Yeah, every user got the identifier from the user UA, and they got their public keys. They use the keys to encrypt themselves and send their location, the encrypted location, to the user UA, and then UA calculated by using one operation, but he doesn't know anything about the real location. Then he sends the location, the ending location, the sum of the values of the location to the provider. Then the provider decrypted it and divided it by key, and he knows the central. He provides the services according to the central. Let's talk about the drawback later. The obfuscation method. This method is different from the first method. All the locations provided by just one user, and among them, one location is his real location. And there are three possibilities for this. Once a user sends his locations, several locations, to the provider uses some algorithm to calculate the relationship between different locations, and then calculate the POI. If they have the same POI, then the provider sends this information to the user. But if there are more than one POI, for example 2, then the provider requires the user to get more detailed information and recalculate the POI again. But if the user is not willing to give the provider more accurate locations, the provider decides to send the user just the best it's thought POI to the user. But I think, in fact, the provider can send all the possible POI to the user, and the user can choose from his real location. Here is a policy. Look at this picture. It is just one example of the location hierarchy, and these are the weights. Omega I, omega U, omega T, omega A are the weights for the identity, usage, time, location, and the sum of them is 1. And LP is the willingness of the user to disclose his real location. And the VI, VU, VT, VL are the specifying factors that are required. This method is so complicated, and the users have to decide so many factors, so it's not convenient. Let's talk about the second. It only considers 3 weights. That is the usage, the time, the location, and the PUIJ, PTIK, PLIM are the combination of the identity and the usage, identity and the time, identity and location, respectively. And in order to make it more safe, and it is also a way to applicate this method. We use this method to the key anonymity, as can be seen from this equation. It is a linear equation, and you can see there are two ends. One end is 1, and another end is, or one end is LP. Let's see, LP equals 1. One end is 1, and another end is K max. That is to say, you can choose how many companions you want, and LP means higher values of LP corresponding to specifying location information at fine granularity. Then let's talk about the visual sensitive information. There are 3 methods I list in my paper: background blurring, filter methods, cryptographic obscuration. Let's first look at this method, background blurring. This is a procedure of the method. We can get the foreground map from the Kinect, because the Kinect produces 3 maps: color map, depth map, player index map, and we use a depth map and a player index map to get a foreground map. And we combine the foreground map with the depth map, we get the sensitivity map. The sensitivity map gets information of the possible sensitivity, including the foreground as a background. So the last procedure is to use a diffusion process. You can decide to what level you can apply to this. To what level of blurring you can apply to this picture, this video. And this is a final result. It is not clear, but the result is very good. And let's talk about some algorithms mentioned inside. This is a foreground map, Rx, and it is decided by the player index map and also the depth map. And this is a sensitivity map. It is decided by the foreground map and the depth map. The last phase is diffusion process, shown here. Here are the 5 filter methods I list: pixel filter, edge detection filter, shadow view filter, deep shadow view filter, and the blur filter. I just mentioned it in the paper. These are the results. This is a pixel. Edge detection, blurring, blur, and deep shadow. And I compared them. For example, the first one, the pixel filter and the blur filter. They are all computational inexpensive filters, which are different from the other 3. They are computational expensive filter. And the color of the pixel filter, the area, is the main color of this area. But the blur filter, the color is the main of its neighboring pixels. And we can also see from this filter, because there is an experiment I mentioned in the paper. According to this experiment, the safety assessment for the pixel filter is better than the blur filter, but users are more willing to choose a blur filter because you can see the moving things more clearly, but not see the sensitive part. Here's a comparison of the shadow view filter and the deep shadow filter. Deep shadow filter is an improvement of shadow view filter. And you can see from the shadow view filter, there is a black area. If there is an activity in this area, yeah, the color will be brighter. But if the user stops doing the activity, the color will be darker again. But this method is only limited to the static environment. And if you move, you expose more detail about yourself. The leaf shadow filter, yeah, is an improvement of this filter because it blends the leaf video with brightening and darkening blocks of the pixels, so you can use it in the moving environment. The edge detection filter shows the outline of the picture, and you cannot tell the detail of the characters in this picture. Also, this method I mentioned can be used to monitor the number of people pass through one area without intruding their privacy. This is a cryptographic obscuration technique. First, it detects sensitive area and define how large to cover this area and encrypt this area. Finally, it stores the key and give it to the trusted third party when there is an emergency. For example, the warrant, urgent warrant. The third party can give this key to the police. From this picture, we can see some sensitive parts are covered, but one area of the tree is covered too, because it is not accurate. And look at the scene, the picture is not so nice, right? So in the paper, I talk about 3 categories of privacy issue in multimedia and the methods for them. I talk about the advantage and the disadvantage of some methods. And also, I compare the filter methods. Here are the suggestions for future work. Just like the first method in geotag, I suggest to use a one-time key. Every time a person wants to see this picture, he sends a request to the picture owner, and the picture owner can send him one-time key to see the picture once, if permitted. And the second method, yeah, I just said it's cool, but it should be better by combining with policies, because you cannot upload every picture and choose the accuracy. That's not convenient. But if you have the interface to your management of the policy, you can do it better. And yeah, this, as I mentioned, the POIs, the provider can give all possible POIs for all locations to the user, so the user can choose from it. As for the connect method, just the background blurring method, I think this method is not so mature for the outdoor use, so the future research should focus on the outdoor use for this method. But it gets good result. And the filter method, I think there's a need for them to combine together. For example, the highly sensitive information can be covered by the computational expensive method, and the less privacy part can be covered by the less computational expensive method. And the last one is improve of the quality of the scene, and also the accuracy of capturing the privacy sensitive information, as you can see. here to improve the quality of this scene. It's poor, the scene, and also to improve the accuracy of capturing the right sensitive part. And just one thing I forget to mention. It's here, the policies. The users has the access to the user interface, and he can manage the policy as well as the context. Once the policy is made, and there will be a new generation of the policy, and this will be distributed to the LBS provider, so they can provide more accurate information or more bigger information. Yeah, that is the end of my presentation. Thanks very much for your attention.
Quick question?